Mathematical Platonism is the philosophical belief that abstract mathematical objects, such as numbers, sets, and shapes, exist independently of the human mind and physical world. According to Platonism, these objects are timeless, unchanging, and exist in a realm of their own, and our mathematical discoveries are seen as uncovering these eternal truths. Do we like that definition?
It's okay. The thing is, I'd be careful when you're saying, numbers, sets, and shapes are all abstract objects. There's certainly some Platonists who believe, sets are abstract objects. But if you can reduce these objects, entities down to something else, and take those as primary, then you may want to say something else is an abstract object. I would simply just make Platonism the statement that there are real, existing abstract mathematical objects, whatever you want to call them, objects.
Okay, that's your definition of it, and that's sort of what we will argue for and against, I guess. P-Star, is there anything you wanted to add?
I'd like to ask a question about that. So it sounds like you're saying that you hesitate to ascribe reality to any particular mathematical object. Because I'm curious about that.
No, I actually don't. I think there are a large range of abstract objects that you can assign individual type to. For me, one of your objections earlier was that you'd almost have to accept everything's an abstract object or something, or there are countless many abstract objects, and under my view there are a ton of abstract objects. So I guess I don't really care about that so much. But I wanted to clarify the positions some people take.
Yeah, that's fair. I don't actually, to be clear, I don't have a problem with the idea of there being an infinite number of them. And I don't even have a problem with the idea of them being an uncountably infinite number of them. That just seems obvious from the bare nature of the proposition because, even if we limit the definition of mathematical objects to just numbers, we know that real numbers are uncountably infinite. So that the cardinality of this is not my issue, to be clear. But what I actually think would be is that, and I'll get to this later, I would actually say that accepting any abstract mathematical objects requires that you accept all abstract objects, not purely mathematical ones.
Right. Okay. Yeah. I maybe misspoke there. I don't mean to say I just take that there's uncountably many abstract objects such as numbers. I mean there are many types of abstract objects. Yeah.
Okay. So
okay, that makes sense to me.
Let's I got the first question, which I think is the appropriate first question.
Can I?
Yeah.
I do want to really quick. I'm sorry. I just want to ask another clarifier, and then you can
Sure.
go, Peter.
Sure.
I'm sorry. To be clear, Jambar, when you said earlier you talked about your reduction, if there is such a reduction to a so-called simpler object, would you say that the original object that you reduced is not an abstract object? For example, you mentioned you hesitate to call sets abstract objects because there may be a more simpler, a more fundamental concept. If sets are, if you can reduce something to something else, is it that's more fundamental, or is it your claim then therefore that the original loses its abstract nature, its abstract real nature, or do both exist?
The thing is, in order to define one, you only need the other one. So you can think of one as primitive, and then think of the other one as not really existing at all, but just comprised of the one that really exists. So that's the idea.
So you would say that the only mathematically abstract objects that exist are the primitives, but nothing else exists?
No, I have a much wider view of that, which I think we'll get into later. But
well, this is important, though. This is really important, and I do want to answer this question because what you just said is that if something can be reduced to something that is more primitive, then the original thing no longer exists in the metaphysical plane, and the primitive thing does, which implies that if the more you reduce something until you get to primitive atoms, then only the atoms exist. You could just do that recursively, right?
Well, look, it's not just that. Wait, someone's echoing. Is that you?
I don't believe so because I'm wearing a headset, but it's possible, I suppose.
Uh, can someone test who's echoing?
I was muted and he was muted, and you still echoed a tiny bit.
Wait, him or me? Wait, is it him or me that's echoing?
It's kind of hard to tell. You're not echoing right now.
Okay, so now, is there an echo?
It's echo?
Okay,
Okay. Looks like we're good. It's not that those, you know, more complicated objects that are built up of sets per se, um, don't have reality. It's just that their reality comes from more fundamental objects. So,
That makes sense to me. Thank you for clarifying. Go ahead with your question, Peterson.
Okay. Well, the very first question is a mathematical object a real thing?
well, yes, and I suppose we're actually both going to say yes, but I think mathematical objects are real abstract objects.
Debate is embedded into what you mean by real. And I think that's what we're talking about here. Because presumably, Jambar, unless I'm incorrect, you're talking about a metaphysically real versus I would say it's real in the sense that it's, something that exists in the world, in our world, in terms of its information,
Right.
which are different. So, yes, but asterisks.
Okay, a lot of ground to cover here. The first thing I wanted to speak is what do you think a number is? How are you defining numbers like 2, 3, 4, etc., real numbers, things like that?
I personally think that a number is a symbol.
Oh, a number is a symbol. Okay. So,
It's a little more complicated than that, but that's one way of thinking about it. If I had to be more specific, what I would say is that a number is an abstract concept that a symbol can refer to in the context of of mathematics as a linguistic game.
okay, so if I'm getting this right, well, mathematics numbers are not symbols, then they're used to designate uh, concepts. Is that correct?
Well, I would draw a distinction between, for example, the integer and the symbols used to represent that integer.
Okay, yeah. So the integer is something that exists conceptually, uh, and you use the symbol to refer to the thing that exists.
I would be careful there because I think that might accidentally import your position. Existing conceptually doesn't necessarily mean that it exists in the real sense. It more means that when we run certain kinds of simulations, we are simulating those objects with, like, the simulation's rules.
Yeah, I don't want to mean to import my position. And when I speak generally in regard to your position and I'm using the word uh, abstract object, I'm referring to an anti-realist position about these abstract objects. So for the future reference, when I use abstract object, in light of your position, I'm referring to the anti-realist position about abstract objects and not my own position. So
All right.
there's another question that I asked before, but I want to get clarification is what is the number one? You're saying that it is a concept, but that doesn't help me pick out the number one in comparison to the number two, etc.
Yeah, I would say we could actually go with any number of definitions for the integers. One definition that I like is, you could talk about it just in terms of two mathematical objects being distinct from each other. And so if you start with just an atom object and then you say we have another object where the comparison equality is not the same, then by definition you've created a second object.
Yeah, but the problem is like I still can't pick out 1 and 2 from those definitions. I can tell you that 1 and 2 are different objects, but I can't define 2 in terms of 1, etc.
Yeah, you can. I'm saying you just iteratively do that. Like that's one actual way like the natural numbers are constructed in both of our philosophies, right? Like you just start with an entity that's the unit, and then you define an addition operator which creates another one, and then you iteratively do that such that each successive one is distinct from the last. If you do that, you've created a set which is isomorphic to the natural numbers.
Okay. Ideally, okay, I think I know the schema you're going for is like if you want to define the natural numbers, you can start with the empty set, and then you inductively define the other numbers as the set of the empty set is 1, etc. like
That's
that.
one way. There's a billion ways.
Okay. So yeah, I would somewhat agree with this, but when we get here, I do think that regularly we existentially quantify over these numbers. So, for example, we can say that there exists an x such that, you know, x plus 2 equals 4. And it would seem that this involves existential quantification over numbers. And if you're going to existentially quantify over numbers, I do think you're committed to their existence in some sense. I'll let you.
So you draw a card in Monopoly that says that you now own Boardwalk. Are you committing to the existence of Boardwalk as a physical place that you actually own?
Wait, when you're saying I own a boardwalk,
Yeah, I own Boardwalk and Park Place in
well, you're
Monopoly.
referring to the boardwalk in Park Place. You're not referring to a boardwalk in.
But are you, by using that language, committing to the proposition that Boardwalk and Park Place are real places that actually exist? I mean, we literally are saying that in Monopoly, these are real estate properties that we own, and we call them owner.
Yeah,
We
you're
call it
referring
ownership.
to the boardwalk in Monopoly.
Ah, so you can use words like ownership or existence in the context of a game, and that doesn't imply really any commitment to their real existence. You can just refer to their what that means in the context of the game.
Look, I mean, when you're existentially quantifying over things, it's taken that you're going to believe if it's legitimate that you are committed to these objects. There's a reason, for example, Quine rejected second order quantification because he didn't think it's legitimate to quantify over properties. So I do think that someone who holds to mathematical nominalism is going to have to reject existential quantification over numbers or claim that it's not a legitimate thing to do.
I mean, I would agree with that, I think, but I don't have a problem with that. Like, to me, existential quantification in the concept in the context of a mathematical statement or a proof is a description of the usage of the word existential in the context of the game. It doesn't mean that it actually exists.
So like many of the statements we use, for example, can be transformed into existential quantification over numbers. And I mean, it's just a little bit awkward to say that we do it for a bunch of other things, but we just don't do it for numbers. I mean,
No, I don't have a problem with the idea of the transformation, but I'm not saying that existential quantification doesn't happen. I'm saying that when existential quantification happens in the context of mathematics, it's just a game, right? Like it's the same thing as saying, I own real estate in Monopoly. It's the same thing as saying I got married in the board game of life. It's the same thing as saying that when I play Dungeons and Dragons, that I have a +5 sword of healing. I don't actually own a +5 sword of healing. These things are not real. I merely am talking about the verb to own or the verb to exist in the context of a simulation that we all understand.
so Then there's going to be multiple types of existence operators under your view.
Uh, yeah, basically. Like, I think kind of what we're talking about, right, is like, to me, the existence operator in a material sense is a different thing than the existence operator in the context of playing a mathematical game or the existence operator in the context of playing D&D, right? Like, if I'm in D&D and my dungeon master says, you see in front of you a flaming sword. The flaming sword is not real, but it's real in our simulation.
Uh, but okay, there's an additional problem I think is that these two statements seem to be meaning preserving. So for example, take the statement that there there was a solution to x plus 2 equals 4, and that there exists an x such that x plus 2 equals 4. Uh, if the two statements are meaning preserving, then you are ontologically committed to the mathematical objects. But if
Both
they're not,
statements, both statements are equivalent. If that's what you're getting at, I have no problem with that. Are you saying something else about meaning preserving? What do you mean by that?
well, yeah, meaning preserving is a type of linguistic equivalence. That the two statements ideally express the same thought.
Yeah, I have no problem with that. I have no issue with that whatsoever.
So, if these two statements express the same thought, it does seem that you are committed to mathematical objects, unless you're identifying this existence operator as something completely different than we use in ordinary language.
No, well, kind of. What I'm getting at is that when we say existence operator in the context of a mathematical game, it means existence in our simulated world that we are linguistically discussing. It just doesn't mean existence in a real sense or an abstract sense. It doesn't mean existence in the sense of anything like is actually real, right? Like I will trivially agree to you that the sentence uh you own a flaming sword, like your character owns a flaming sword, and your character has discovered, picked up, and then claimed ownership over a flaming sword. Those are semantically equivalent statements, right? Like they're just two ways of constructing a syntax that semantically expresses the same thing. And I have no issue with that semantic equivalence, but that doesn't upgrade the semantics of what we're describing to be real. It's still a simulated fake linguistic game representing something that
Look,
we're
look,
engaging
even
in together. It's not real.
look, even in the
The,
case of the game, it is real. You are referring to a real fictional object, which is the sword.
what
And
does
yeah,
it mean for something to be real fictional?
well, philosophy of fiction is a big field, but there are many philosophers who think that fictional objects do have reality. And their
Okay.
reality is, of course, represented by their fictional status, and they do
I
it to
mean, that's
express
great.
these.
This gets really quick to where I was eventually going, which is that I believe genuinely that if you believe that mathematical Platonism is real, then you are committed to a Platonism for all objects. I mean, we I was going to go about it a more roundabout way, but if we're there, then we can just be done.
Well, I'm not necessarily agreeing with these philosophers that uh, fictional characters are, you know, real things, but uh, actually, I am agreeing, but I don't think
Ah,
my position entails this. Like, agreeing's not the right word. I just don't think this is an entailment of the view.
okay. So would you can we do the entailment? I mean, it sounds like you agree anyway, which is interesting. And honestly, I'm a little shocked by that. Not necessarily because it's even a dumb idea. It's great. It's a good. I'm impressed with your consistency. I just thought I'd have to work harder to get you there. But like you would say that it's not an entailment. I believe I can actually show that it is an entailment.
Oh, well, okay. Maybe you should define what an entailment of a view. Are you using it the same way as?
Well, I think that it would create an inconsistency to claim that, uh, for example, the number two is metaphysically real, but Puff the name Puff the Magic Dragon is not metaphysically real.
Okay, wait. So by sorry, by what is inconsistency? Do you mean you can derive a contradiction?
Yes.
Okay, go on for your case.
Okay. Um, So essentially, the case that I'm going for here, I want to actually talk about something at first that you brought up earlier, and then we'll get back to that. Is that okay?
Okay.
I wanted to ask earlier. You said that you don't necessarily hold that propositions themselves are mathematical objects, but
Propositions are
mathematical
abstract
objects are.
objects, and they exist.
Okay, okay, but are they metaphysically real?
Yes.
Okay, just to be clear about that, so we agree on that. I was just going to call that out because I mean I'm sure you're familiar with Gödel.
Yeah.
Yeah, perfect. Okay. So I'm going to kind of go a step further and I'm going to kind of just, and you said you study computer science, so this should be easy for you, but I'm going to kind of show that because of like the Church-Turing thesis, any rule set can be emulated by a simple set of atoms that are mathematically defined. So any proposition in any formal system, and any object in any formal system, and any information at all about anything can be represented as purely mathematical Turing machines or as purely mathematical integers.
Okay.
So, I mean, do you disagree with that claim? I mean, I can go into that in detail, but that
Well,
is kind of standard.
yeah, I mean, look, the system that I prefer to use to describe mathematics in general um, does take mathematical objects in each system I'm using to be abstract objects.
Right.
Um, and
But
yeah.
so I think what I would say then is this. What I'm going to do is I'm going to show that because of the Church-Turing thesis, if you have any formal system as an abstract object, then all formal systems are abstract objects.
Okay, that's fine. I accept
Do you
that.
agree with that?
Yeah.
Okay, cool. Would you agree that any information can be represented as an integer or is derivable as an integer?
Any information can the symbol one can be used to designate anything, but that doesn't mean the number one is anything.
No, that's not exactly what I mean. What I mean is, let's say that I write down a description in as many characters as you want of Puff the Magic Dragon, or I write down just the name Puff the Magic Dragon. Now, I understand that the name Puff the Magic Dragon does not include the entire information for the entire concept of that dragon, but at least the name itself, that set of letters. Would you agree that that set of letters is something that can be represented as an integer?
Oh, okay, but the thing is, when you realize when you're doing this in two different systems, you do realize they're different abstract objects under my view, right?
Why would they be? Well, I mean, sure, they're different abstract objects, but why are they not, in terms of their existence, why does the existence of one not imply the existence of the other?
Well, under my view, they're both going to be they're both going to be objects relativized to a certain mathematical theory.
Yeah, I agree with that completely. I mean, that's kind of my point.
But this is like strictly speaking under a certain semantics I accept. But I don't see for the general Platonist who just accepts that, for example, abstract numbers exist, how this is going to hold for them.
Well, because if numbers exist and are discovered, not invented, and all information and all propositions and all formal systems can be represented as integers through Gödel and Turing, then the mere admission that the natural numbers exist would actually imply that all information and all formal systems and all systems are exist in the metaphysical abstraction.
That okay. Just because all the things can be represented as numbers,
I mean, it seems to me that, like, okay, so like let's say that I write down the I have a dream speech, right? And I write it down in English. Presumably a purely natural number Platonist would not say that I have discovered the I have a dream speech. Yeah?
I don't think the mathematical Platonist would.
Okay.
You know.
So, yeah, and I agree. So if I write it down in Russian, Does that change the nature of it?
You're expressing the same thought if you write it down in
Correct.
Russian or down in English.
Right. What if I write it down base 64 encoded?
It could designate the same thought. Sorry,
Okay.
I think it's the same
So,
thought.
and that what if I change that base 64 character of like sequence of strings into an integer?
It would express the same thought.
Okay, so this thought of the I have a dream speech in its entirety is an integer, which if it already
Well,
exists
no, 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 no,
metaphysically.
no, 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 no. You're conflating something that's used to designate a thing with the actual thing. It's not an integer. It's used to designate an integer.
I'm not sure I get the difference in the sense that if you hand me the integer that represents the encoding of the I have a dream speech, I can fully reproduce it. This is not merely like a reference that requires extra information or semantic referent. It's actually the information itself is encoded inside this integer.
Okay.
It's not merely a referent.
Can I
If
can I
you're-
just can I just say something real quick? P Star, are you saying that what we have here is something like a mass energy equivalence? Like they actually are the same thing?
Yes, kind of. I mean, in the sense that you can like if I just hand you a box with nothing but a poem that I have written that you've never seen before and no one has ever seen before, and I encode it as an integer, you can recover the exact poem that I have written. This implies that the integer is not merely a referent to a shared concept, but is actually fully enough information to find the thing.
Oh, okay, if it's fully enough information to find the number, it doesn't mean that it is the number itself.
I mean, I don't know what it, but would you at least agree that both of them then would be mathematically abstract objects? If they both exist if one of them exists in the material sense and the other one sorry, in the, not material sense, in the abstract sense, or not, sorry, metaphysical sense. I'm going to start over because I was just very confused. Let me start over. If writing it in Russian is this, it doesn't change the nature of it as writing it in English, which doesn't change the nature of it which writing it in a Caesar cipher, which doesn't change the nature of it as writing it in blue pen or writing it in green pen. The nature of it is not changed. It seems to me that the information content of a thing, it has a function which is a simple, easy to define mathematical function, which is a one-to-one mapping between integers and, like, strings in a particular encoding system, which would
Uh,
seem to imply that therefore if an integer is a real thing and that function is a real thing, then the string itself is also a real thing.
okay, so a few things to address here. So I think the mapping's backward. The mapping should be injective, or it should actually be bijective. No, 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 it's inject. Wait, no, it's not even injective because
It's
the
one to
string
one.
can refer to multiple things.
No, it can't. It's one to one.
Well, under this function, it's one to one, but it's not injective in the sense that we use natural language. Like the
But if
strings,
the, I don't know what that means. I'm sorry.
strings don't have uh, meaning independent of speakers. So the strings themselves can express different thoughts. It's the meaning the speakers give to those strings. And
I will agree to that. That's not my issue. That's not what I'm trying to say. I would agree with that.
okay, so
That's fine.
the function should go from the meaning of certain strings to integers, um, which is the other way, and it
Oh,
would be an injective function.
to be clear, I'm not making necessarily the claim that the meaning is the function that it's trivial to produce. I think that that's mind dependent. What I'm saying is that the string itself, like the mapping between the integer and the string, is constructible and well defined and would therefore have to be an abstract object.
Well, okay. No, it wouldn't have to be an abstract object. Just because you have one thing in the, what is it? Uh, codomain. No, sorry. So one thing in the codomain, which is abstract. It doesn't follow that the domain and the function itself have to be abstract things. In fact, you can use this function in this way. Uh, you can say that the strings are ways of picking out the abstract objects, but the strings or the meaning we express by those strings is not itself an abstract object, and neither is the function. And
I agree with you. I'm not talking about the meaning really. I'm talking about the string itself. I'm literally just talking about linguistics, and I'm talking about like the fact that like literally encoding of data as symbols is itself a mathematically well-defined thing.
okay,
Like,
the strings themselves, or the things you're saying are encoding the data, is a mathematically well-defined thing. You're just saying that those strings contain information. Now,
which they do, yeah.
yeah, the information can be used to designate the numbers, but the information itself is an abstract thing. Neither are the symbols you're using.
Well, hold on. So you would say that information's not an abstract thing?
Well, okay, I'm talking about the meaning, what people are expressing.
Yeah, I have no issue with the idea that meaning is not an abstract thing, but that's not what I'm referring to. I'm strictly talking like pure information theory.
Look, there's no pure information that you're speaking of. There's only what a speaker intends to mean when they use the string of symbols. There's no
Uh,
information in and of itself.
no. I'm talking about information theory, like the idea of the way that strings of data are isomorphic to integers, and like I'm just talking computer science here.
Yeah,
Like I would agree with you that the computer itself has no understanding of like you know I don't even know how to say this. If I have a photograph in binary bits and bytes uh, of an apple, the computer doesn't have feelings about the apple merely because it's storing that photograph on the hard drive. But what I am saying is that that apple can be encoded, like that photograph itself, not the apple, but the photograph can be encoded as zeros and ones. And anything which
yeah,
can be
the
encoded as
photograph.
zeros and ones is information which is an integer.
Okay, the idea of encoding these things as integers is really just letting the integers themselves represent the objects after they're interpreted by the computer.
No, that's not exactly what I'm saying. I'm just simply pointing out that. So I think another way to explain this might be this. You know how we have different base systems, right?
Yeah.
Would you agree that writing a number in a different base system is interesting, but ultimately not like it's still an integer regardless of the base that it's in?
Yeah, they're used to designate the same mathematical object.
Yeah. And so, therefore, if I write an integer in base 10, if I write like 5,686 in base 10, that's the same thing as writing that integer in base 26,
No,
right?
it's not the same thing in terms of the symbols you're using, but it expresses the same thought by
In terms
designating
of
the same
the
object.
well, in terms of the abstract realism that you're talking about, metaphysically, is it the same
Yeah,
thing?
it's used to designate the same object, yes.
But metaphysically real, when we talk about the things that are metaphysically real, are we like would you agree that like regardless of base, the integers are metaphysically real?
Yeah, they exist
Okay.
independent of what you're trying to express.
Right. And therefore, like well, let me put it another way. You said they exist independent of what you're trying to express. That's would you agree that if I choose base 35 and I choose base 3 and I write the same number in both bases, is it the same? Is the metaphysical object the same?
That the object that they're used to designate is the same object, yes.
Okay. And so if I write down in base 26 and I pick symbols for PUFFTHE to be my symbols to represent the sequence of integers mod 26. So like, each of the letters A, B, C, D is the symbol that I use for my base 26 integer. Then PUFFTHE MAGIC, that is a unique integer in base 26.
It's a unique integer in base 26?
Yeah.
Okay. But it's used to designate the same integer?
And so I could write that same integer in base 10.
Okay.
And so therefore, if I believe that integers exist regardless of the base that I write them in, then if I write a base that like represents the information of anything that we've ever written down, then that is also an integer, literally just by doing base conversion. I'm saying that like information theory and basic like computer science, it shows that like any sequence of symbols that you write down in any order can be converted into a base representation using the alphabet of strings.
If you're just saying that there's a countless number of things that can be used to designate the number one, anyone would agree with you.
It's not the number one in specific. What I mean is literally like, all right, so I want to ask, would you agree that in base 10, hold on a minute, I feel like this is a really important point, and I think it's interesting, and I appreciate you tolerating going along with this. Give me a second to make sure that I have it correctly.
Okay.
So, one second. I just got to do something on my calculator.
Okay.
While you're doing that, we've been going for, I think it's been like 45 minutes-ish. And this open discussion, I'm fine with it. I've liked it. It's been good. But I did have questions. But what I think I'll do is I'll treat them like, when they do a debate, they do the open discussion, and they do like audience questions. And so these aren't really audience questions. But we'll go with that. We'll maybe go like, I don't know, 20-ish more minutes on this. If you guys feel like we got to a point where we're just repeating ourselves or going in circles, then let me know, because I won't know that we've got to that point. And we can end it earlier than that, or move on earlier than that.
Okay, I got what I was going for. Okay, so would you agree that if I write down 48879, that is a string which represents an integer in base 10?
Sure.
Okay. Now, if I write down BEEF, which is and I tell you this is in base 16, right?
Right.
Now, obviously, interpreted as English letters, this has a meaning to you. Beef. It's a meat. It's a cow. It's all these things, right? I'm not talking about the meaning. I'm talking literally about the symbolic representation, BEEF. Would you agree that that is the same thing as 48879?
Okay, but look, if you're talking about these symbols, irregardless of what they represent, then they're just meaningless symbols which aren't used to designate. I guess in symbolic logic, there are two parts. There's just symbols that don't have any interpretation, and then there's the semantical side that gives you the interpretation. When you want to deal with designating numbers, you have to give interpretations that allow you to designate. There's no number one without meaning, because you need meaning to designate the number one.
Yeah, I'm not saying it doesn't have meaning in the sense that numbers don't exist. In that, well, okay, so I kind of am, but what I mean is that we agree that in the context of at least this game, that the decimal 48879 is an integer. And it's the same integer whether I write it in base 16, base 2, base 10, base 40, right?
Actually, no. If you're talking about it independent of meaning, it's not an integer. It's not the abstract object. Because the
Okay,
abstract
but
object is grasped at by the meaning of the symbols.
okay, but fine. So the string 48879 refers to the abstract integer.
Yeah, and
Would you agree?
referring is going to depend on the meaning, yes.
Okay. The problem is I don't really know how to represent integers without some kind of symbolic representation. So I don't know how to describe these abstract integers without referent to you. So we can't even have the conversation. Is there a way that we could just mutually agree that, like, if I say the integer which the string 48879 represents, then you agree with that?
Yeah, of course you can say that, but don't speak as if you, like you were speaking earlier, as if independent of the meaning of these expressions that they designate the objects. That's not true. But if you're just saying that I'm using a number one to designate this object, I'll perfectly understand what you're saying.
Yeah, what I'm saying is that I'm using the standard decimal integers to designate the abstract object that of integer, like the set of integers. I'm creating an encoding between symbols on paper and the set of integers. Does that track for you?
Okay, yeah, you can do that. That's fine. Yeah. But
I
then I
mean,
don't get the
you
critique
don't?
that you do.
How do you talk about numbers if you don't use their names?
We don't. It is, but you
So,
designate objects in reality by their names.
right. So that's what I'm getting at is I'm saying can we just agree to talk about numbers together and know, like, by using their names without having to go through this?
Uh, yeah, but I'm curious about the critique you brought up earlier that you can define this function that maps certain strings to integers. Or you said it was the other way around, but
It's a
that's
one-to-one function.
yeah, it's an injective function where
It's
integers.
one-to-one.
Yeah, it's injective, right?
Well,
Uh,
it's injective means, but it's both ways injective. It's not just injective. It's both.
so it's a bijection.
Yeah.
Okay, so you're saying that there's this bijection where you're mapping integers to strings, and this means that the strings are abstract and the function's abstract. That is what I disagree with.
But earlier when you said that if you have an object which is defined in terms of another object or can be defined in terms of a reduction to another object, then both of them would remain mathematically abstract.
Well, you can have the function itself doesn't have to be abstract to map integers to strings. The relation itself doesn't have to be, you can think of functions as relations if this helps. The two-place relation mapping integers or between integers and strings does not have to be abstract for it to take in types of abstract objects.
But what would it? But I thought that part of your proposition earlier is that, functions and mathematical propositions and that operate on mathematical objects are themselves always going to be mathematically abstract. Are we going to go back on that and say that certain types of computations are not mathematically abstract? Like, are not mathematically real?
Well, obviously, I think many Platonists don't accept that like addition is abstract. They'd accept that the number two is abstract, but they don't think addition itself is abstract. So obviously, they don't think computation defined on abstract objects is itself abstract. But yeah, there's
But
a distinction you have.
Gödel and the Church-Turing thesis, like, literally shows that that's not true. Like, we can represent any computation in terms of pure propositions, and we can represent propositions in terms of Gödel numbering. Like, the integers themselves can like
That's just
represent computation.
that's just symbolic stuff. It doesn't speak on metaphysical theses that you're trying to get at here.
But then I guess I don't know how I would be able to tell for a given mathematical construct whether or not it's metaphysically real. I mean, earlier you said that if we can derive it to the integers, then it would be metaphysically real, or if it's a mathematical construction that operates on integers, then it would also seem to be mathematically real. But now we're saying certain mathematical constructions are not real, but certain other ones are. It seems arbitrary just to get out of the trap.
Well, look, certain mathematical constructions aren't real, but others are. It just depends on what you're talking about is mathematical constructions themselves. But I
So,
don't think it's arbitrary at all. I'm just saying that you don't have to believe that everything's like an abstract object in this way to hold that numbers are abstract objects. And two, to define other sorts of properties of mathematics, you would probably have to hold that some entities are mathematical abstract objects, sorry. But it's not going to.
but wouldn't you agree that if we're defining numbers as metaphysically real, and we also define that these, things which are isomorphic to the numbers are metaphysically real, then like why would like if you're defining a purely mathematical operation on an integer and you can derive another set, then wouldn't that new set be real as well? Like if I have, let me just ask. So like if I have the set of integers, right? Like the set of natural numbers, and then I have a mathematical function which is like a pure math function in some way. Like it literally just defines operations to transform from one string to another, like from one integer to another integer. Like that's all it is. So I have f of x goes to y, where x and y, the domain and codomain, are both integers, right?
Right.
If I have that, is both x and y, and we know that the integers are all natural numbers. If f is a natural, would f be a mathematical abstraction?
Well, why would f be a mathematical abstraction?
I mean, it's a function. Like it's just a mapping. Like it's just a one-to-one mapping from the integers to integers that I've just like defined.
Okay, and why would the function itself have to be abstract?
Well, presumably any function mathematic, like that's I guess what I'm asking is, are we saying that integers, like the set of integers, is abstract, but like nothing else is, as in no functions, no operations, no computations, no transformations,
For
no mappings?
for a complete view, you'd have to. Well, I think it's most plausible to hold that some other things are abstract. Like probably want to hold that the propositions are abstract.
Well,
You
but
would
propositions and functions are the same thing. That's what the Curry-Howard correspondence says.
no.
Totally, absolutely. There's a
That's
one-to-one
very
there's a one-to-one correspondence between logical proofs and computable functions. You can isomorphically transform them to each other.
look. There are many theories on propositions, but I wouldn't. The general definition of what a proposition is, it's something that people express. It's the object of belief and other propositional attitudes like knows, conceives, etc. But saying that functions are a proposition, some people like Stalnaker think this, it's a view that is not encompassing of a lot of views of propositions. There's tons of philosophers who don't think propositions have the metaphysical status of functions.
I mean, yeah, but those philosophers are wrong. Like, are you familiar with the Curry-Howard isomorphism?
Look, I don't think I'm
No, I'm
not
not trying to
familiar
say
with
like an
what
ass.
you're
I'm not
talking
trying to
about
be an
here, but
asshole. I'm just
I'm not familiar with what you're talking about here, but I'm sure that many philosophers do not take propositions to be functions. You
yeah.
can
Okay. Well, those. I guess what I would say is, if you don't mind, I don't know how to do this without being condescending, but can I just read from Wikipedia?
Yeah, you can do that.
Okay. This is the Curry-Howard correspondence, and you can Google this yourself. In proof theory, the Curry-Howard correspondence, also known as the Curry-Howard isomorphism, or the proofs as programs and propositions, proves a direct relationship between all computable computer programs and mathematical proofs. Origin, scope, and consequences. In its more general formulation, the Curry-Howard correspondence is a correspondence between formal proof calculi and type systems for models of computation. The basic proof here is just that the Curry-Howard-Lambek correspondence. Joachim Lambic showed in the early 1970s that the proofs of intuitionistic propositional logic and combinators of computational combinatory logic actually are the same equational theory, the theory of Cartesian Coe's categories, and therefore now like all of them are isomorphic to each other. Like you can take any logical proof in a formal system of like pure logic and you can convert it into a lambda calculus like function mapping computer program.
Well, okay, lambda
and vice versa.
Yeah, lambda calculus is a type of functions. And
yes.
Okay, but look, it's not speaking on the metaphysics of these propositions. Sure, they could have these mathematical representations, but in addition to the mathematical representations of these objects, what are propositions? What are these functions? I mean, it's just mathematical representations. It's not showing ontology.
I mean, that's what I would say, yes.
Yeah, so...
I mean, that's the whole point, right? Is like mathematical constructs are simply linguistic rule sets and games and computational steps that we go and do in an order, and that it's all just kind of like a linguistic computational game operating on symbols all the way down. It doesn't actually show anything about the ontology of these objects. I agree. That's my thesis statement.
Look, I'm saying this doesn't show the ontology of propositions. Now, it's silent on the question of whether mathematics are abstract objects or not. I gave you a couple cases in which I think gave evidence for that, like using existential operators over numbers, using modal operators over numbers. I think this is going to be good evidence for them being thought of as abstract objects. But
it doesn't necessarily mean like we both agree that you can use existential operators, but all I would say is that the use of an existential operator in the context of saying a mathematical proof, for example, is merely just using invoking a game that's being played in the mind of the reader. It's a computer program that's being played in the mind of the reader. It's making a statement that exists in a simulation of a logical system, but that just because that logical system can be played out doesn't mean that it has metaphysical reality.
Look, when you're using then you're just claiming that the existential operator itself is illegitimate, because if the things you're claiming exist don't have this form of reality, then you're not saying anything exists. So the use of the existential operator under your view is going to be illegitimate, and that was kind of my point, as I think this is a way to get you out of the ontological commitments that you don't want to accept, which ideally are that numbers are abstract objects.
Well, no, but what I'm getting at is that okay, so to get back to what we were saying, with regard to propositions no longer being abstract objects, that's fine, but Gödel says that numbers and propositions are basically the same thing, or at least are isomorphic to each other. But we can put that aside for a second, because it does require that isomorphism requires that some functions are abstract objects. And so if literally no functions are abstract objects, then you can't create isomorphisms.
Okay,
fine. But
I'll just accept that claim, because first of all, it just depends on which ones you think as primary. If you can reduce numbers down to functions and one functions as your primary object, then claim they're abstract. If you don't want to do that, then you can claim that the numbers are abstract. I'm fine with accepting this.
Well, no, because what I mean is that it's weird to me to think of the idea that numbers are real, are metaphysically real, but functions aren't. but I'm saying I can accept that as an axiom for now, just to move on to what you're talking about the existence operator. Does that make sense?
But your idea was that you could think of numbers as functions.
Well, yeah, that's what I'm saying though is like Gödel shows that like they're literally the same thing. Like every number uniquely maps to a function.
Yeah, that's okay. Every number can uniquely map to a function. That also doesn't imply that the numbers themselves are functions. Every Look, every real
I
number, every natural number can uniquely map to the set of uh sorry, every natural number can uniquely map to the set of what is it? Integers. That doesn't mean real numbers and integers are the same thing.
That's true, but in terms of them, it would be weird for you to say then that integers are not abstract, but natural numbers are. Do
Oh,
you see what I'm saying?
no, it's not weird. Just take a function that maps from types of abstract objects to types of concrete objects.
But that's what
Why
I'm
is that
saying
weird?
is like if this function is purely mathematical and the objects themselves are all like symbolically represented in your function definition, like I don't see the it seems weird to me to claim that like, well, the natural numbers are metaphysically real, and functions that map the natural numbers to the integers are not metaphysically real, and also therefore the integers are not necessarily metaphysically real. That seems weird as hell to me.
What? Okay, you'd have to specify what exactly are functions.
Right. And so, like to me, a function is a one-to-one association.
Well, no, I mean
But
clearly it's not one to one because there's functions that are clearly not one to one.
sure, yeah, you're right. Yeah, sorry. To me, I think you and I both know what functions are. I don't have to pull out my definition. I mean, am I
But the thing is, like, I don't think this function requires. Well, if you take numbers to be abstract and numbers to be reducible to these functions, then you can hold whichever one primitive abstract object you want. But functions themselves can informally be thought of as taking one thing and transforming it into another.
Let me
And in
ask you a
that sense,
question.
it's not abstract.
What if I tried it this way? What would do we agree that the set of natural numbers is itself a metaphysically real object?
The set of natural numbers is a metaphysically real object.
All natural numbers are metaphysically real. This seems like
Well,
the
that's a different
simplest, most
claim.
conservative case.
That's the different claim. Saying all numbers are metaphysically real is different than saying that the set of natural numbers which is real.
Yeah, I know. I Are all natural numbers real?
Sure, yeah.
Okay, that's easy enough for me. Okay. Now, what about all functions that map from a natural number to another natural number, as in all associations that take in a natural number and return another natural number? Are those metaphysically real? It literally the only thing it takes in is a natural number. The only thing it puts out is a natural number, and it puts
I
out and
honestly,
doesn't.
I just am not seeing why you would need to take these things unless you're thinking of them as just like equivalent to numbers themselves, or numbers are expressible in terms of functions. I don't see how, through a more primitive lens of what a function is, you'd have to claim that these things are metaphysically real. But I don't even see the
No,
problem.
I'm not saying you have to. I'm asking you. I'm
Oh,
asking you,
under
let's
my
say
view,
that I
sure they
have
will.
some arithmetic operation, like I'm going to take in the integer x and I'm going to just define, like, then you take x and you, like, divide it by 5 mod 12, and then you add 26, and then you square it. That's a function that takes in a natural number and returns another natural number.
If you're asking through my view, of course I think functions are abstract objects, but I just didn't think it was an
Okay.
entailment of the Platonist positions.
No, I don't think it is either. I'm asking you if that is something that you hold, and would you say that that is like, do you believe that such a function that takes in an integer and returns an integer is itself an abstract object, if I can like define it?
Yeah, I think functions are abstract objects, yeah.
Okay. So, regardless of what other Platonists may or may not believe, you believe that as long as the input is one integer and the output is one integer, then that function is a mathematical abstraction, right?
Well, yeah. Well, I think that is a mathematical abstraction, but it's more general than that. You can ideally plug anything you want into domain and codomain and map them.
Okay. Well, what I'm going to say, and this is kind of where we've been trying to get to for like an hour, and I'm so sorry about this, is if F interprets X as a binary string, right, and then does a Turing machine on it, which is very easy to define using simple arithmetic. I could write it in a couple, like 15 or 16, like, like a universal Turing machine in like 15 or 16, like arithmetic operations, like divide, mod, multiply, subtract, right? If I do that, is the function that I've defined with these arithmetic operations that takes in an X and outputs an integer Y, right? And it just happens to do so through this like Turing machine mapping, is my F, which is just constant defined. It's just a definition of a set of arithmetic operations that I'm performing on X. Is that a mathematically abstract object? Like a mathematically real object? Or metaphysically real, sorry. Metaphysically real object.
Yeah, I do think that's the function's a metaphysical real. And I just want to clarify one thing, is that we shifted the conversation to me accepting a weaker claim that, through my view, functions are abstract objects, rather than through Platonist views that entails that functions and other things are abstract objects. So even
I accept that.
You might want to accept other views.
I accept that. I accept that it's possible for a Platonist to say that only the natural numbers are real, metaphysically real, and nothing else is, including operations on them and things which are equivalent to them. Like, that's fine. I just would find that to be weird. But since you and I at least, like, but you would at least say that you do hold to the stronger claim that, like, a function on natural numbers to natural numbers is metaphysically real.
Right, yes, and that's because I think of mathematical theories in general as abstract objects, and I think they have a lot of abstract objects in them. And
So this gets back to what I was getting at this whole time, which is that all you need is for one function from the natural numbers to the natural numbers and the natural numbers themselves. If both of those things are metaphysically real, then you can bootstrap them to representations of all information and all computation and all formal systems.
Okay.
Cool. And so to me, it seems like the belief that a single function representing a universal Turing machine on an integer is real, and also that natural numbers are real, those two beliefs are all you need to include into every video game that's ever been run, every physics, like every simulation that's ever been run, every D&D game that's ever been run. Well, that one's a little bit, no, forget the D&D games thing. But like every formal system that you could even possibly conceive of that operates on any information to any other information can be emulated by just a function on natural numbers and natural numbers. And so it seems to me that if only those first two primitives are metaphysically real, then everything else is metaphysically real.
Wait, no. Look, what one designates, if one designates some concrete object, it's not showing that, well, if one designates a unicorn, for example, it's not showing that unicorn is real. It's showing that the symbol 1 designates anything. You can use the symbols to refer to whatever you want, but this is not showing that anything is real. The metaphysical interpretation that you take of 1 can be anything, but if we're talking about 1 designating the abstract object 1, it's different. I don't understand this critique.
Okay. I know we definitely have done this conversation before. We did it earlier.
Yeah.
And you will have the opportunity to unpack that a little bit more. But I do want to go to some of the questions because we've done about an hour and a half now at this point.
I appreciate this. Yeah, and I agree.
Yeah, no, it's a lot of fun.
I'm sorry.
And there's never a good time to cut it off. There never is, but it also can't go on forever. So, I that was cool. I will listen to this again in my car on the way to work one day, and maybe I'll understand half of it when I listen to it again the second time. But it's very good. So, my next question would be, and I'm going to set like a 5-minute timer for these. So, next question. Do you think mathematicians actively hold to mathematical Platonism as they do research, or do you think it's a post hoc justification for mathematical structure and things that are theorems and whatever that are found, discovered?
Well, I don't think mathematicians, hold to Platonism because I don't think they know enough about the foundations of mathematics to hold these sorts of views, and I don't think they're interested in it. Uh, but I think that it's philosophers' job to tell you, to ground the metaphysics of what they're doing, to show epistemological concerns of what they're doing. And if it's our job to do that, I don't think we're making any post hoc justification. It seems like we're doing our job.
I would actually agree with you about that. I think that mathematicians actually are probably, if you just ask them what they feel, I think myself included, intuitively they would um, subconsciously hold to mathematical Platonism without realizing it, just because it's an aesthetic part of what it means to feel like a mathematician, in my experience. Um, I think that they also don't consider it or think about it at all. So my instinct would be is that largely mathematicians do not like consider themselves to be mathematical Platonists explicitly, because as Jembar said, they don't think about it or investigate it or are familiar with the foundations of the metaphysics of this enough to care. But I think intuitively they operate and probably believe in this without realizing it.
So let me ask a follow-up question. Do you think that it's required to do better math?
Him or me?
Either one.
Well, actually, I think that philosophers of math need to study math. And the best philosophers of math I knew or know now do study math, and they also study philosophy. If one really wants to know the foundations of mathematics, they should themselves be studying mathematics. There's no other way to know. And most philosophers, I think, are unqualified to answer questions about mathematics in general. And vice versa, most mathematicians don't care about philosophy. Yeah.
Okay. But you think they should, in order to make, like, if there were going to be some sort of like paradigm shift in mathematics, you think that studying this would be like imperative for that?
Yeah, and I mean, a lot of philosophers do study math, theoretical computer science, and they have successful research. So yeah.
Okay. P-Star, anything you want to add to that?
And I've used the D&D analogy a couple times, and I want to get back to it when we talk about, because we kind of dropped the legitimacy of the existence operator question, which I want to get back to eventually, but if we don't have time to get back to it, then I just want to say, like, for me, in a lot of ways, this question is kind of like playing games, and I don't think that you necessarily need to understand the philosophy of you don't need to understand the philosophy of game design or the philosophy of mythological archetypes in order to be good at D&D. You can play D&D without knowing any of those things, and you can be very good at, like, you can be unbelievably good at Fortnite and not know anything about how to code video games, right?
A lot of great musicians know jack shit about music theory.
Right, or even a better, I think, argument with the musician's argument would be you can be amazing at guitar and not know how to build guitars. So I think of the rule set and computational, like the linguistics and rule set that and underlying theory behind the construction of mathematics to be the rules of the game. And then being a mathematician is to play the game. And being good at both might be valuable, but I think you can be very good at playing a game without an understanding how to construct the game or the
Okay.
tools. It's a tools versus the usage of the tools kind of thing, in my opinion.
Okay. That was exactly 5 minutes. So we'll do the next one, which is if this is a bad question, then just tell me it's a bad question. We can pass on it. But do either of you have like a position or a take on the idea of like the unreasonable effectiveness of mathematics? Do you think that's a strong case for Platonism?
Wait, the effectiveness? Why math is so effective in
There was a
society?
guy, Wittgen, I can't remember what his name was, but he wrote this paper in the 60s called The Unreasonable Effectiveness of Mathematics. And I don't think he was a Platonist, but he said, like, look, there's no reason for us to expect that math is so incredibly successful at describing the world around us. And so I could see that some people would think that that's a strong case for these Platonic mathematical
Oh, okay.
constructs really existing.
Yeah, I'd say yes. I know my opponent might disagree with me, but the reason is that some people claim the physical theories we hold to involve math as explanations. And there's some research done in quantum mechanics where they use the equations to explain what's happening physically. And the concern is if you don't have some form of mathematical Platonism, how exactly are is the mathematics doing the explanation? And what, the author is saying there is that mathematics wouldn't fit the world so well if these numbers didn't have ontological status, which is something I think is at least convincing.
I think that the argument is very convincing, and I'll give credit to that position. To be honest with you, and I will say it's a hard one to argue against. What I would say though is I would say that um, there's a couple different ways to look at this, and I'll try to keep it quick. But like the first way of looking at it is we can talk about, is money real? Is money real? And the answer, according to economics and sociology, is no. Money is a symbol that we've created as part of a social construct that creates like basically debt instruments and contracts and law. And it's all very complicated and tied up in terms of like society, but it's not like a physically real thing. And I think that that's a little bit how math is, in the sense that math is something which can represent anything. And that's kind of what I've been trying to get at this whole time about the idea of like the Curry-Howard correspondence and Turing machines and processes and functions. You can use math to represent any sequence of steps or simulate anything. And to the degree which we would want to use simulations to predict the world around us, well, of course we can use math to create those simulations, because that is like, and those models and those predictions, because that is literally what math is for. It's a system which can be used to predict and simulate things. I would say it's not necessarily proof of any kind of metaphysical claim, though. It's just showing that once a system is sufficiently computationally powerful, it can be used broadly to run any kind of prediction. And I think that that is not an ontological claim, or at least you don't need ontological claims to reach that level of power. So math is powerful, but that's a statement of computers, not like, a statement about like spiritual essences.
Right. Okay. Okay. Um Sorry, my cat meowed. It distracted me. I didn't know she was even in the room. What the heck was the last Okay. Is Platonism purely metaphysical and beyond empirical verification, or could it conceivably be proven?
Platonism is a metaphysical thesis that says there are abstract mathematical objects. Now, it came earlier in philosophy that you needed some pure intuition to get at these mathematical objects, which was kind of suspicious epistemologically. No one really knew what the faculty of pure intuition was and how exactly got at mathematical objects. But now I think we have a stronger idea of what abstract objects are and what I think the work of neo-logicists in this field are doing shed some light on how we can grasp ontological objects that are abstract. We simply need to understand what the mathematical proposition is saying, and it's going to be analytic under the lens of neologicist. So as long as we can grasp what these objects are, what they encode, we can grasp whether the mathematical statement is true or false. And through that lens, we have access to the truth, and I don't think there's a substantial metaphysical issue with the positions anymore.
I don't necessarily see. Sorry, was the original question about empirical proof?
The question was, is it merely or purely metaphysical, or could it empirically, could you ever have empirical verification of Platonism?
It seems to me that the answer is no, but I don't want to speak for Janbar. Is that basically the short answer, Janbar?
Well, look, I said you can have knowledge as to what mathematical propositions are true or false when they are abstract objects. Through the neologicist view, I can go into that if anyone wants, but
What about Okay, so this is related to that, and before we jump into this, I just want to. This might go a little bit, so cut it off if necessary, host. But what about you, with what you just said about like the application of like knowledge of something as true or false, provided it can be formulated as an abstraction or as an ontological object, like what about undecidable problems?
So there's like the idea that those things aren't expressing propositions if you want to hold to classical logic. At least there's two ideas that I've heard, is that if the statement can't be proven true or false, you might just not want to say that that statement is well defined or expresses a proposition, even though it appears like it does. Or you want to say that in these mathematical systems, they sort of don't provide you the resources to determine the truth of all propositions. But this is a special issue, which I don't have a particular position on.
Doesn't it important if we can say that certain propositions can be formulated which can't be, like, you can't use to resolve the truth or falseness of an issue? Like, doesn't that seem like an important issue to resolve within the Platonist view?
No, because Platonists are fully, they're not, you can be a Platonist and accept that there are, well, some propositions are underdetermined in their truth value, meaning that there are truth gaps. There's no issue with that. You would just hold that there's an indeterminate, true, false, and indeterminate. You would reject classical logic.
Well, citables though, it's more like if it's true, then it's false, as opposed to being truly indeterminate, right? Like the undecitables result from contradictions that are imposed.
Yeah, okay, you can hold that certain propositions are indeterminate to stop the contradictions from happening. I don't know what you're asking here.
Okay, that's fine.
Are we? Is that really all we need to say on that one?
Without getting into the weeds of like weird halting problem shit, I think that's fine.
Yeah, probably. Maybe a to be continued. The next one is when a mathematician discovers a new theorem, are they creating something entirely new, or are they merely uncovering a pre-existing truth that's always been there?
I think there. Well, there's no, under my view, there's no correct axioms you take. In a way, they're discovering what is in fact usually analytically true. Um, so they have a certain set of axioms and they're trying to derive something. So in the context of pure mathematics, they're discovering that it's analytically true, but maybe you don't want to say they're discovering something new through the lens of my view either.
P-Star?
I think this cuts to the very core of the overall debate. So covering this accurately require re-investigating the entire thing. But if I hope someone doesn't mind quoting something in the content, and that someone in the comments says axioms are consistent, correct? For me, I think that's really important, and I think that like basically we talk about discovery versus invention. I would say that when you're doing mathematics, you're playing a game, and you can play the game in such a way that a new strategy that wins you've never seen before. I don't know if that necessarily ontologically means you've discovered it, even if it feels like a discovery. And the reason why I think that is because it comes back to everything that I've been trying to get to this whole debate, which is that if discovering a particular theorem is the same thing as discovering an integer, basically, which it is, because if you discover a theorem, you could write it down as an integer, then to me, that would mean that, discovering anything in any formal system which can be written down as an integer is discovered, and then that would just imply that everything humans have ever created, like the I Have a Dream speech and the entire text of the Bible and the entire text of like Tolkien and a photograph on my Instagram page, all of those things were discovered. And that just feels weird to me.
Okay. I actually wanted just I know there's a 5 minute limit, but I just wanted to say something is that this perspective is not constrained to people who aren't Platonist. As I said earlier, I'm a Platonist, and I don't think it's correctly characterized that we quote unquote discover numbers. I think you have a certain set of axioms, and mathematical theories are abstract objects, and most of what's done in pure mathematics is deriving consequences from your axioms. So in this way, you understand them analytically, they're necessary. And themselves, there's not much discovery here so much as deriving things. Okay.
Can I ask clarification on that? When is deriving something not discovery?
Well, I take it that even you believe that when, let's say in first order logic, you're doing some derivation, that this is quote unquote not discovering a new object so much as using certain axioms that you have to come up with a consequence. When they're saying that you're, discovering an object, it almost seems like you're going outside, walking, using some faculty you have to access these abstract mathematical objects, which isn't right. It doesn't seem like that's what's being done. And I assume you have a similar picture, because I think almost everyone thinks of deductions this way.
We got it. We got 1 minute left, but does that basically say everything we need to say about it?
Let's go to whatever the last part is, because we have 1 minute left.
Sure. Well, no, it was 1 minute left on that question. I have like three more things. So this next one, P-Star, I'm gonna have you go first on this one, and it's not really even a question. All I wrote down was the Tower of Babel. So you and I had a discussion on this close to a year ago, where we were talking about mathematical Platonism, and I said, you described something, I re-listened to it last night, now I don't remember exactly what it was, but I said, this sounds a lot like the Tower of Babel. And I think that that's a little bit appropriate on what we were just talking about. So if you can just like give your position on like what's the implication for that, and where this would all fit into what we've been talking about. Or did I say tower? I meant library. The Library of Babel.
Say
Sorry, the library, not the
That's
Tower of Babel. That's not a thing.
Yeah, the Library of Babel. Yeah, I mean, I think the Library of Babel really speaks to what I was trying to get at for a lot of this debate, which is to say that basically the metaphysical the metaphysical realism, like in a way the mathematical Platonist position can be summarized as saying the Library of Babel is a real place, like a spiritual plane that you could go to and you could visit the Library of Babel. That's like the way that I understand what mathematical Platonism is. And to me, I think that there's a website called like the Website of Babel or something like that, which actually implements the Library of Babel as a website that you can search. And because of the way that it works, literally every text is on this website. And so once you play with it, you'll start to get a sense of what that means, and you'll get how it works, and you'll go, oh, okay, haha. But I think that it's difficult because, to me, I think the claim that that website actually contains all the books ever written, I think that is the claim that I find so hard to accept about mathematical Platonism. Yeah, sure. You start to figure out how it works, and you go, oh, that's kind of clever, but it feels really magic for a second. But I think the problem is to me, it almost seems like the mathematical Platonist view is that the Library of Babel is a real place, and that makes me that seems implausible to me.
Okay. Actually, I already kind of addressed this. What I said last time is, well, for my view, it's that you do have certain axioms which you derive things from, which is usually what the person who rejects Platonism is getting at. But you also have that these mathematical theories are themselves abstract objects, and they contain abstract objects in them. But I mean, so far as we're doing the epistemological thing where the discovery, is just looking at the axioms and deriving things, my picture is not really different from the picture they're laying out, and I'm still a Platonist, so I guess that's one thing to note.
Okay. Do we want to keep going on that for another minute, or are we good?
I think we're good, but unless he wants to.
Okay, that's fine with me. Second to last one is, so if mathematical Platonism is true, what might that have to say about perhaps like other domains of study, or what might that imply about other abstract ideas? I'm not trying to straw man, but like, couldn't we argue that there's such a thing as dog heaven if there is an abstract, really existing realm of mathematical concepts as well?
So like this gets to something that I mentioned earlier, is that naturalists tend to be like really opposed to certain views about numbers like I hold, but through a more relaxed view of what naturalism is, I don't think it's too pressing to hold naturalism and hold to the existence of abstract mathematical numbers. If we construe naturalism as the view that anything that our physical theories need to be validated, we need to posit ontologically, then I do believe some of our physical theories require us to posit abstract mathematical entities. And just because they exist in a way that seems sort of strange to us isn't a good reason to reject them, at least under my view. And I also gave the case that our language seems to suggest that they exist. So, I mean, maybe it's not so strange to, have these abstract mathematical entities at all. But yeah, that's what I have to say.
Okay, P-Star, I know you feel strongly about this because one of your things when we discussed was, I mean, if the Platonic realm or whatever is real, then it's like math heaven, and if you're gonna believe in that, then you might as well believe in like actual heaven or something to that degree. And we were just kind of having fun talking about it, but
So I think that I'm going to, because I've already kind of this formed the crux of what we talked about for about 45 minutes earlier. So rather than readdress that, I will try to steelman my opponent's position a little bit. And what I will say is that I think that it is not required to believe in other abstractions semantically as dog heaven just from mathematical Platonism, because it is coherent to believe that the semantic meaning of only natural numbers exists without inherently believing that dog heaven is a real place. I think that is possible. However, I think that my view can be accurately summarized as natural numbers can represent every possible descriptor of dog heaven that you could ever record. And so a description of every dog heaven does seem to exist. And that seems a little weird. Even if the semantic, like ontological meaning of a dog heaven as a metaphorical place does not, mathematical Platonism does seem to imply that a description of every possible dog heaven is written down somewhere.
okay, I like that. The final thing is, if not Platonism, then what? Or does it not need to be the case that there needs to be something in place of Platonism?
Well, ideally, you have to be a Platonist, believe that there are abstract mathematical objects. You can be agnostic on the issue, or you can believe that there aren't any mathematical objects. Um, so you're either going to have to be agnostic or hold that there aren't any mathematical objects. And there might be a good case for agnosticism. There are a good amount of Platonists, even though like the layman usually finds these positions to be extremely unintuitive. It's much more popular to philosophers than many people think of. So I think the alternative to Platonism might be to be agnostic simply because a lot of the experts in this field are uh, undecided about which thesis is right. Anyway, that's my take.
My response would be that it doesn't seem to be required to believe in a metaphysical space or a metaphysical or spiritual truth in order to play the game. I don't have to believe that my D&D character is real in order to play D&D and enjoy it and be good at it. And I think that that's so I don't think that you need a replacement or anything if like in the sense that that mathematical Platonism is a metaphysical claim that isn't related to the material world, you don't need to have that claim or believe that claim or hold that claim to be true in order to operate within the world, right? Like it's kind of like, you know, I know that you may object, Jambar, to this comparison, but I'm going to make it anyway. Like, if not, the God of the Bible, then what? Do you just believe in nothing? And do you believe in no ethics? And my response is, well, no, you don't have to metaphysically believe that the God of the Bible is metaphysically real in order to have belief systems about how you should behave. I think that you do not need metaphysical claims about the nature of natural numbers in order to do interesting things with them.
Yeah, actually, I just wanted to draw like very quick kind of asymmetry between the two things, like belief in God, belief in numbers. I mean, even people like naturalists like Quine who are very against these weird abstract entities existing, uh, actually held that some abstract entities have to exist for our naturalist theories to hold. So, if naturalists who are very opposed to the idea of abstract objects, some of them actually like to include mathematical objects in their naturalism because they think they're required as explanations. Usually, people do not posit things like God. So that would be the sort of asymmetry between the two. But
He sounds like saying that like Darwin was a Christian, so therefore, like that doesn't seem to be like I'm fully aware of the fact that people like Gödel and Quine were like at least some kind of mathematical Platonist, but that doesn't necessarily mean that the position has on has epistemological value. I think.
look, I'm just saying that, like, when you say it's like the belief in God or similar to belief in God, I just don't think this is true because we have, well, people who are a lot smarter than me, have looked into this field a lot more than me, and are very convinced by what naturalists are saying and are very opposed to these entities, abstract entities, have to posit them. That seems to me like, there's something different than, God here, and it may be very plausible to hold Platonism. That's all I was trying to get at. Not that they're correct or just some evidence.
Okay. Well, that concludes everything that I had planned and everything that I wanted to ask. And we did do 2 hours. So I think that's a pretty healthy discussion. But,
there is only one thing that I would suggest we get back to if you want to, Jambar, because we let it drop, and I told you a little while ago that I would let you talk about it with me. It was about the invalidity of the existence operator. Host, is that something that we have time to briefly go back to? If not, that's fine. I don't need to cover it. I just want to make sure that I don't take it away from my opponent.
do you think it can be done in 10 minutes?
Maybe not. I don't know. I'm just offering if my opponent wants it.
Well, I've said a lot of things on the existence operator. It's actually something we spent a lot of time on. If I couldn't flesh it out to you in the amount of time we spent, I doubt I'll be able to convince you in 10 minutes.
Okay.
So,
I just knew that I had it written in my notes that I actively put it aside, and I just wanted to make sure that you didn't feel cheated from that. But I'm willing to let it go.
Okay.
Okay. Well, it sounds like Jambar said everything they feel like saying about it. Yeah, I don't know. I think we will leave it there. It was definitely really cool, really interesting. Mostly, though, it was confusing. And that's not a bad thing. That is, you have to learn how to think about things that are difficult. And typically you only learn when you're thinking about things that are really difficult to think about. So hopefully it's constructive for everybody that listened. This will go up on YouTube if anybody wants to revisit it. I know I will have to. But that's basically it. I was going to do a live stream today, but now I don't know if I will. I definitely need to take at least a short break. But
can I respond to that really quick? Briefly?
Yeah, go ahead.
I just want to say that I would love to do this again, and I really appreciate, Jambar, your time, and I really appreciate your time, host. One of my philosophies that I really like is Richard Feynman once said, if you can't explain something in 1 hour to a group of 19-year-olds, then you don't understand it. And so I try to endeavor to make everything that I talk about like easily digestible to a layperson. And it sounds like I didn't do a super great job here because I think I was focused too hard on the debate part. But I would, I'm just saying I would love to go into any of these things with a more layman topic with either of you at a later date.
Maybe I should, just before I go, say closing. I just want to host and the guests for participating in this conversation with me. I'm very interested in mathematics, so it's very fun to have, and I'm also interested in philosophy, so it's very fun to have. I hope I didn't bore anyone or, had too much confusion.
Okay, I think we'll end it there.